Hey guys, welcome back. And in this video, we are going to learn about introduction to IoT Pentesting in this TryHackMe lab. So this is a beginner-friendly walkthrough for Internet of Things pentesting. So let's begin this journey. And in the introduction, you can see you have to deploy this mission by clicking the Start Mission option here. So I already started that. After waiting for 2 to 3 minutes, it just gets fully booted. After fully booted, then you can just click here for deploy the mission task, and we are moving to task 2, where we are going to learn a little theory about it, about a firmware. What is a firmware? Firmware is basically a small piece of software that makes hardware work and do what its manufacturer intended it to do. Without it, the devices we use won't work. Like, assume that you have a mobile phone. In that mobile phone to get worked, like if the mobile phone needs to work, then it should have a software. So that software makes the hardware work in a manner that the user or the vendor needs the phone to work intended to, right? So without a software, the hardware won't be able to work. With only some hardware, it doesn't operate. You have to control it using the software, right? So that is why software is also important. In this case, we can also call this firmware, right? It's basically a small piece of software that makes the hardware work. Like every device should have a software to get it worked, right? Assume you have a laptop. Without the Windows operating or any other operating system in the laptop, the hardware like the RAM, graphics card won't be operate correctly, right? With that particular software, then only these things are getting to work as what they are intended to work, right? So that's about the software and hardware. Both software and hardware is essential to get things work. Okay, so that's the one thing that you need to know, that you need to remember. Okay, so how to obtain it? There are many ways of obtaining the firmware, like the vendor's website. You can update the firmware from the vendor's website or the manufacturer website, and you can just Google it to get, and you can just reversing the mobile application to get its software, and sniffing the OTA is the over the air update mechanism to getting an update, so dumping it from the device. So these are some of the ways to get the firmware. So where was the firmware used? The firmware we are about to analyze was by Netgear for a few of their access point products. Besides that, the vulnerability affected multiple firmwares. You can take a look at them here. So this is the common vulnerabilities exposure of 2016-1555 is the ID number that we are going to explore, and which is by Netgear, and this is what we are going to exploit in this particular video, right? So after reading that, you can also read this if it is working. So in my case, it's taking some more time to get it load. Here it is. You can see it's about Netgear and WN604 and other models, multiple PHP files, remote command execution vulnerabilities in this particular CVE is intended to, and you can see some of those. Here it is, right? Like the board data 102.php and the board data www.php. These are some of these vulnerabilities affected these files, right? The remote code execution vulnerability, remote command execution vulnerability, right? So after reading that, you can just click here and it's done. Now we are moving to task 3 to connect to this mission. You can just connect it using SSH using the username IoT, and this is our password, and this is our target IP. So yeah, what we can do is you have to connect to OpenVPN if you are using Kali Linux, or if you are using attack box, then you can just directly use SSH. Okay, SSH and the username IoT at the target IP, and yes, and after that you have to enter the password. So let me copy and paste correctly. Here it is. So unfortunately it was file. I don't know why, maybe because of any error that I copied. So let me copy that correctly. Okay, without any spaces, I'm just copying that, pasted it here, and it worked. So we were able to log in using SSH, right? So yeah, now we were able to log in using SSH, connect to the machine via SSH. We just done that. So yeah, we are moving to the task 4. The firmware we are going to use is from Netgear and was used for access points. Now it's been superseded by another version. In case you want to download it locally on a machine, you can just use this link to download if you want that. So if you access the desktop folder, you should see the firmware zip archive. So here you can see there is a desktop folder, and here you can see the zip of that particular um, vulnerability, right? So that particular firmware, right? So you can just unzip that using the command unzip, like unzip, and let me put double quote, and it's wn something like that. Pressing enter, it's unzipped. Now we have two files it was able to get, like one is .html and another is .tar. So 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 these are the two files. After unzipping that, we were able to get. So we have the tar file. We can extract the tar file using tar minus xf and the name of the file. Right. After that, when I enter ls, I was able to see something suspicious called root fs.squash fs. This is in green color, which pretty much means that it has execute permission, and this seems to be something in the root, right? So we can read that here. As you can see, drop the release nodes and another tar archive. Let's extract that one too. Oh, we extracted already the tar file, right? So after that, we were able to get an interesting file called rootfs.squashfs, right? So let's use binwag to extract the file system as follows. As per the screenshot, you can use the binwag to extract the squashfs, like binwag minus e for extracting and the rootfs.squashfs. Once I press enter, you can see it's working, and here it is. When I enter ls, I can see that this is what it extracted. So let me move there using the cd, because that's a directory. When I enter ls, I was able to see two files. So again, I was able to see a directory. I'm just moving that, and instead that I was able to see a lot of directories. Here I'm just moving to www. Sorry, I'm just moving to home. So in the home, I have www. So when I move there, I was able to see a lot of files. But one thing that you were able to find from this vulnerability is called board data www.php, right? The same thing was here, right? Board data www.php, right? So this is where the vulnerability is, right? So which is our remote command execution vulnerability, right? So we can just cat that using cat space that, and this is where the remote command execution vulnerability is. Okay, so yeah, let's read this. Okay, so as you can see, drop this file. So take a look inside the folder we already moved inside, and it looks the Linux file systems. And if you go to home www, you will find the web application that is used. We already moved there, right? So yeah, you can just click there. And we are moving to task 5, where we are going to attack the application. The next step would be analyzing each PHP file to try to find a vulnerability. I will save you time, and we will take a look at this board data www.php. This is what we just gathered that before, right? So this file contains a command execution vulnerability. This piece of code that we are interested is this. So this is the vulnerable PHP file, and the vulnerability function is the exec of function, and the exec of function executes an external program without displaying the information. Basically, it's a blind command execution, and the time to emulate the system for this task, we will use FAT, which is a firmware analysis toolkit. FAT is basically based on Firmidine. Firmidine is an automated and scalable system for performing emulation and system and dynamic analysis of Linux-based embedded firmware. With some changes, Firmidine uses PostgreSQL database to store information about the emulated images. So, however, for the core functionality of PostgreSQL is not really needed, hence FAT doesn't use it. So elevate your shell and copy rootfs.squashfs firmware analysis toolkit folder and change the owner of the file to root. So this is what we need to do. For that, we are moving back to the desktop. Like I'm just moving to back, like cd.//. Now I'm in the desktop. So in the desktop, you have to use this command for copying the root squashfs, right? Copying the root the root fs squash fs to the firmware analysis toolkit. So we can just select the enter the firmware analysis toolkit, and after that, I'm just executing again another command. So running multiple commands, you can use the semicolon. After that, we have to move to the firmware analysis toolkit. So we are moving to the firmware analysis toolkit directory. After that, we can just change the permission using the chown command, chown and root colon root for giving the owner of the file to root, and we are just entering the root fs file. So in this command, we are just copying this root fs.squashfs file to a firmware analysis toolkit directory. After that, we are moving to that particular directory, and we are just changing the ownership of the root fs.squashfs file to root. Right. So this is what we are going to do. And after that, we are just listing that using the ll command. So yeah, this is how it looks like, and inside that we have the fat.py, which seems to be useful for us. So now let's let's kick off fat, which is the firmware analysis toolkit, and emulate the system. So this is how you run it, right? So we can just enter /fat.py, which is fat.py is basically the firmware analysis toolkit, which already has the execute permission. So you can just pretty much run using the / command, and after that you can just use the squashfs, right? So unfortunately, we are getting an error in this copy, right? So we can see it's about permission denied and no such file or directory. So there is something that we done was actually wrong. So that's why, yeah, let me move back. So let me check the previous command that I entered. So first, we need to use the sudo -s command. So that's the thing that we missed. So let us use that, like sudo -s, and you can just enter the password, which is TryHackMe, right? So we can just copy the password from here. Here it is. It's done. Now we have the root permission, as you can see, hash, which means that we are now root at this particular IoT. So now we can just use that command that we used previously. Let me copy and paste that properly. Okay, now I'm just pasting that here. Here it is. It does work now. Now we can use the fat.py. After that, the rootfs.squashfs. And now it is working. Welcome to the firmware analysis toolkit version 0.3 offensive IoT exploitation training and by Atify. So you can see it's running, extracting the firmware, and it's working there. So let's move on. Once it's done, take a note to the IP that is outputted. So it basically output an IP like this. It's usually 192.168.0.100, and press enter to continue the emulation. So once the emulation is done, create a port forward on your mission, which is the attacker mission, using SSH. So this is the command that you need to use to create a port forward. So let it work, and let me open a new terminal for port forwarding. Like the command is ssh minus capital N, and after that you can just enter IoT at the IP address of our target mission. This is the IoT's IP space, and the -L command and port 8081 minus capital L 8081 colon. And this is what the IP address, that is what this tool is going to get. So let us analyze the fat, and the fat needs to give us the IP. So here it is. It's basically the same, which is 192.168.0.100. So we can just press enter to get it work. So once I press enter, it is working. So now I'm just pasting that IP here. After that, we can just use the colon for specifying port 80. Let us use colon for and specify port 80. And after that, I'm just pressing enter. It is asking for the password. The password is basically in the task 3, right? So let us copy the password of IoT. So before, when you trying to copy the password, make sure not to include the spaces. Okay, so once you copy correctly, then if it includes spaces, then you will get error. Okay, so after copying that correctly, you will not able to see anything. You only able to see a page like this. Nothing happens. Okay, so After that, now you can just access there like the local host 8081, and we can now access this 8081 page where the Netgear is running on, and the default credentials was admin as the username, and the password is password, and logging in, and we were able to log in. So after login, you have to move to this board data www.php where this particular vulnerability existed, which has the remote command execution vulnerability, right? So this is where we are now reached. And in the MAC address field, add some junk data. For example, you can add something like this. So I just added that junk data and submit it, intercept it using burp suite and forward it to repeater. So we can just start the burp suite for that. I'm just starting the burp suite, and I'm also starting the Foxy proxy. So I'm just turning on the interception and pressing submit. It's not intercepted. Everything was fine. So pressing submit again. So pressing enter. Nothing happened. Nothing happened. So basically, I think I have to configure my burp suite properly. I think maybe the certificate was not there. Let me check that. It does get intercepted here, but why it is not intercepting? Now this get intercepted. When I click submit, nothing getting intercepted. Let me try to access the burp suite for adding the certificate. And I'm just downloading the certificate, CA certificate. After that, I'm just moving to the certificates. It's still not downloading. So maybe because of this proxy or interception on, it's now done. So I'm just adding the certificate. If it is not intercepting properly, then you have to add. This is already installed. So I don't know why it's not intercepting. Not able to intercept that properly. Maybe we have to use the tag box, or when I click submit, nothing is happening. Let me check the inspecting, and let me check the network, and it is working, but unfortunately I don't know why I'm not able to intercept that. Yeah, but still nothing is happening, right? So let me open the burps browser for this. So here is the burp browser, and inside the burp browser, let me try to paste this URL. Now it is working, right? It's intercepted. So let me stop the interception and entering some random junk data, pressing submit, turning on interception and pressing submit. But still it's not working. So let me check here. So it is saying to add this random data and submit it, intercept it using burp suite and forward it to repeater. So when we try to add and click the submit, we were not able to intercept. I don't know why. Let me click reset. Let me stop that. Let me copy the junk data from here and paste it here and click intercept. Now still, yeah, let me turn on the interception and click submit. Yeah, it just worked. So maybe because of any issue in there. So when I use this browser, then the interception was working good. So you can, if you're getting error, then you can also try this same method. Okay, so after that, you have to send this into the repeater. Here is our repeater tab, and in the repeater tab, You can see for this proof of concept, I pinged the local host. So he pinged the local host, and this seems to be some kind of encoding, like a URL encoding or something like that. So let's try to use some URL encoding. I'm just disabling burp suite. I'm searching for URL encoding. So I'm just entering ping 127.0.0.1, which is our local host, and I'm just encoding that. Here is the encoded version. I'm just copying that, and we have to paste it here you by specifying semicolon, right? So that is where the command injection vulnerability looks like. So after putting a semicolon, I'm just pasting that and sending there. I don't know if it is working or not, but according to this screenshot, they are saying that you will notice a delay, which means the application is vulnerable to command execution. So yeah, there is a delay. The request is taking some delay. So that is the meaning this is vulnerable to command execution. So let me click cancel, and let me use the command, like instead of using this, let me use ping. This is basically a Linux system, so you can use -c2 for 2 pinging. So and let's encode that. Right. So after that, we can just try to use that. Now let's try. It will ping for 2 times, right? Still, I'm not able to get any response. So I'm just eliminating this, canceling and sending. And now I was able to get the response. So let's try to use the same scheme that is using here, like plus ping plus -c plus 15 plus. So they used only plus between those. So let's try to use plus, like plus ping plus -c plus let me use 2 plus 127.0.0.1 plus hash plus at the end hash. Let me send that. It will ping for 2 times, right? Here it is. It worked, right? After getting some little delay, it is working. So when I ended the ping to 4, it may take 4 seconds, maybe 1, 2, 3, 4. Boom, it worked, right? So this is so we can confirm that this is vulnerable, and we can just copy the passwd file using the same method. We are just copying the etc passwd to the same directory. So we can just use that command. You can just use plus between before that. First you have to use semicolon, after that plus, then we have to copy the slash etc slash passwd, right? So I think you have to use plus somewhere, right? Like after cp plus, after cp plus slash plus space. I think you needed a space or not. There is no space. Plus slash etc slash passwd. Okay, understand. So plus slash etc slash passwd, and plus dot plus hash at the end, right? Yeah. After that, we can just send this. Now we can see, it's saying that update was success. So let's try to access the passwd file from the web page, which is in the current directory. And I press enter. Let me turn off the interception. Now the passwd file was downloaded and this is the contents. So this website is vulnerable and we were able to get the contents which is from etc passwd, right? So let's also use this curl to get the information, right? So you can we can also use the curl for that also. Like curl will also do the same, like curl and the URL like http colon slash slash localhost colon 8081 and slash passwd. Here it is, we were able to view the contents, right? So this is how we exploited this vulnerability. Congrats, you have successfully attacked your first IoT system. I hope you understand that. And after that, you can just click the check here and you can see some personal thoughts. I hope you enjoyed this walkthrough. I came to the conclusion that pen testing IoT systems or devices is not difficult. It's mainly attacking a web application to gain an initial foothold to the device, or in some cases, the network protocols they are using UPnP. For example, some IoT devices might use some outdated network protocols that have publicly available exploits. Another option would be attacking the hardware hacking, but that involves other things like having a physical device you can tear apart, etc. I hope you learned something new and managed to attach the mission using this room. Yeah, that's also what I think. So I hope this video is informative for you. Thanks for watching, guys, and I will see you in the next one.